Hey, it's Mr. Redstone, and in this video we're going to be looking at geometric sequences. By the time you're done this video, you'll understand what a recursive rule is and how we can find an explicit rule to find the value of any term in the sequence. Just starting off with an example, 10, 20, 40, 80. It's pretty obvious that the next number is 160, followed by a 320. Now, how did we get that? 10 became 20 because I added 10. Sure. 20 became 40 because I added 20. Ooh. Immediately you see that it doesn't have a common difference, meaning I'm not adding the same amount each time. If you were to graph it, the rate of change would be steadily increasing. So this is a nonlinear function. It's pretty obvious, though, that 10 became 20 because I multiplied by 2. 20 became 40 because I multiplied by 2, etc., etc. This factor of 2 is what we call the common ratio. And the common ratio is represented by the letter R, and in this case, it's 2. Now, when you first looked at this sequence, I said it was obvious that the next number was 160, because you went to the number before it and doubled it. And then to get to the 320, you looked at the number that came before it, and you doubled it. The way most brains process these patterns, it's perfectly represented by what we call a recursive formula. And while it might seem complicated at first, the more you think about it, the more you'll understand that it really does mirror the way you think about these types of patterns. All right, here's how we're going to develop this recursive rule. The first number in my sequence, A1, the first number had a value of 10. The value of the second term was equal to the first term multiplied by the common ratio of 2, or 10 times 2. The value of the third term was found by taking the second term and multiplying by 2. This would have been 20 times 2. The value of the fourth term was found by taking the third term and multiplying by 2. 40 times 2. Now I could keep going on, but what I want to do now is generalize it. What if I had the nth term? Well, to find the nth term, I'm going to have to take the term before it. In this case, a sub n minus 1. The nth term is equal to the term that comes before it multiplied by 2. This is what we call a recursive rule. The next term is found by multiplying the previous term by 2. And it's important you indicate where you started from. In this case, we started from the number 10. The recursive rule. And the recursive rule, just to reiterate, it will tell you the value of the next term of a sequence. Let's do 2 examples. What is the recursive rule of the following sequence? 50, 10, 2, and 2/5. The first thing you want to do is recognize what is the common ratio. How did a 50 become a 10? You multiplied by 1/5. That's the same as division by 5. If you want to know what the recursive rule is, you indicate what is the value of the first term, and the value of the first term was 50. And then to find the value of the nth term, you'll take the term that comes before it and multiply by 1/5. That's your recursive rule. I find the next number by multiplying by 1/5, and I start from 50. Example 2. What are the first 5 terms of the sequence represented by this recursive rule? Now, just to make this one a little bit different, I used function notation, but the idea is still the same. The term I'm looking for is 5 times the term that comes before it. Now this time I'm not telling you what the first term is, I'm telling you what the second term is. Interesting. So the second term was 10. And I can find the next term by multiplying by 5. That means the value of the term after 10 is 50. The value of the term after 50 is 250, because I'm multiplying by 5 each time. And now if I go backwards, I can find the value of the first term, which was 2. All right, example 3. What are the first 4 terms of the sequence represented by the rule? Okay, the value of the next term is negative 3 times the term that comes before it, where the fourth term is 81. I'm given the fourth term. It's 81. And this recursive rule tells me that each term is found by multiplying negative 3 times the term that comes before it. All right, the number after 81 would have been negative 243, because I multiplied by negative 3. Now, if I'm going backwards to the left, I'm going to divide by negative 3. The third term would be negative 27. If I divide that by negative 3, I get 9. And if I divide that by negative 3, I get negative 3. And this asked me for the first 4 terms, which means I didn't need that negative 243. And that's it. Now let's consider a generic geometric sequence in order to develop what we call the explicit rule. All right, I've got 6 terms listed. I've got the first term, the second, the third, the fourth, the fifth, and then ... the nth term. I need that starting point. I'm going to say the value of my first term is a sub 1. If this is a geometric sequence, I find the second term by multiplying the first term by r. So the value of my second term is a1 times r. To find the value of the third term, again, I take the term that comes before it and I multiply by r. So I have a1r, that's the term that comes before it, and I multiply by r again. So a1rr, or a1r squared. To find the value of the fourth term, again, I take the term that comes before it, a1r squared, and I'm going to multiply it by another r. I combine my exponents to get a1r cubed. I'll do that one more time. To get the fifth term, I'm going to take the term that comes before it, and I'm going to multiply by r. Which is the same as saying a1 r to the power of 4. Now, patterns are beautiful things. It doesn't matter which term you're looking at. They all seem to have that purple a1. They also seem to have an r. But what's the exponent on the r? For the fifth term, I raised it to the 4th power. For the fourth term, I raised it to the 3rd power. The third term, it was the 2nd power. The second term, it was the 1st power. And for the first term, it was the 0th power. The exponent on r is always 1 less than the term number. So for the nth term, the exponent on the r would be n subtract 1. And what we've just developed is the explicit rule. The value of the nth term is equal to the value of the first term multiplied by r to the power of n minus 1. Now let's just indicate what all of these variables represent. A sub n, that's the value of the nth term. A sub 1 is the value of the first term. R is your common ratio, and n is the term number. Let's do some examples. Given the formula f of n equals 10 times 2 to the n minus 1, what is the first term? The common ratio. Finally, list the first 4 numbers of the sequence. Well, if you understood the explicit rule that I just wrote down, this is a really easy question. But the big mistake students will make when they first start out here is to mix up this, in this case, the 10 and the 2. Which one is my first term? Which one is my common ratio? Because, there's multiplication there. They get mixed up. So what I'm going to do is fill in a table of values to figure out the first 4 numbers in this sequence. If n equals 1, that means the first term. What I'm going to do is replace n with 1. 10 times 2 to the power of 1 minus 1. Using order of operations, I do the exponent first. 2 to the power of 1 minus 1, that's 2 to the 0. I have 10 times 1, which is 10. If n equals 2, I have 10 times 2 to the power of 2 minus 1. That would be 20. If n was 3, 10 times 2 to the power of 3 minus 1, which is 40. And lastly, 10 times 2 to the power of 4 minus 1 is 80. You'll notice that I'm multiplying by 2 each time. 2 is my common ratio. The value of my first term, a sub 1, that's equal to 10. The first 4 terms of the sequence, 10, 20, 40, and 80. And just to review what we did at the start of this video, if I wanted to write that as a recursive rule, I would say the first term is 10, and the value of the nth term can be found by taking the term that comes before it and doubling it. Example 5. Given the sequence represented by a sub n equals 4 times a sub n minus 1, where a1 equals 10, what is the rule for the nth term? So we're looking for the explicit rule here given a recursive rule. I always find it handy when I have a recursive rule just to write out the first few terms of the sequence. That just helps you get your mind right about what it is you're looking at. A1 is 10. Easy enough. The next number is found by multiplying the previous number by 4. So 10, 40, 160, 640, ... Okay, now that I see it written out, I can pick off my common ratio, which is 4, because I'm multiplying by 4 each time. The first number in the sequence was 10. And that's enough information now to determine the explicit rule. The value of the nth term is equal to the value of the first term times the common ratio raised to the power of n minus 1. To test this out, and there's nothing wrong with checking your work, suppose n equals 3. We know that when n equals 3, we should get a value of 160. Well, let's substitute n in for 3 and see what happens. A sub 3 equals 10 times 4 to the power of 3 minus 1. 10 times 4 squared is 160. So it checks out. Last question, example 6, and then we'll call it a day. What is the explicit rule for the sequence -4, 8, -16, 32, -64? First thing you want to do is identify the common ratio. How does the -4 become 8? I multiplied by -2. So my common ratio is -2. The first number in the sequence is -4. So the value of the nth term is equal to the first term times r to the power of n minus 1. Let's just substitute in what we know. The value of the first term was -4. R is -2, and we're going to raise that to the power of n minus 1. There we go. Thank you very much for watching, and I will see you on the next video. Bye for now.